Hello everyone, today we're going to talk about basics of kinematics in terms of displacement, distance, and position. So what is position? Position is the location of some object according to the origin. So on the right here, we have a point P, and it's from the origin 0, 0. So now we can find the position, which is 2, 1, right? Because as it moves 2 to the right and 1 up. And now there's another way of representing position, which you can say plus x meters to the right or minus x meters to the left. This is also another way of representing position. Now, distance is the overall movement of an object. And displacement, the overall change in the final and initial position. So now, let's say these points A and B right here. And here is my path. This path here is the distance. But the difference between the position is the actual delta x, which is the displacement, the overall change in the final and initial position. Now let's take a look at an example. So a boy walks horizontally for 5 meters. Let's draw that 5 meters. Not drawn to the scale though, and then turn right and walks for another 8 meters. So let's say this is 8. And we're asked to find the distance. So the distance is just equal to 5 meters plus 8 meters, which is 13. And the displacement delta x is just the difference between the position. Now, if you take reference points as this way positive and this way positive, then going down means that the displacement is negative, which is 5 squared plus 8 squared, and taking the square root of that, which is root 89 meters, but negative here. Now, let's look at another example too. Thomas goes to school from home, which is the origin, and halfway to school he forgets his backpack, and he returns home. After he returns home, he doesn't want to go to school anymore, so he decides to go to the library. Now let's calculate the distance and displacement. So the distance. So let's first draw the path. So he moves to the school. Like the distance is 6 meters here, but he only goes halfway, so it's 3 meters. And then he returns home, which is another 3 meters. Later on, he goes to the library, which is 6 meters. Now, we forgot to draw the signs, which we should do. So here's negative, here's also negative, and here's positive. Distance. Since distance doesn't care about direction, we'll add them up regarding the signs. So it's 3 plus 3 plus 6, which is equal to 12 meters. But the displacement cares about the signs. So delta x equals to xf minus x initial, which equals to negative minus 0, which is negative 6 meters. Okay, so this one is interesting. Tom walks around the track for 1 full lap. The radius of the track is 10 meters. Calculate the distance and displacement. So the circumference is equal to 2 pi r, which, and then 2 times pi times 10 meters, which gives us 20 pi meters. That is the distance because it's the path that he traveled. And now let's take a look at the delta x. Since he started and finished at the same position, his x final and x initial are the same. So there's no displacement. Okay. Example 4. A person takes the path as below, and we need to calculate the distance and displacement. This is gonna be 2 and 4 because position. And here 1, 2, 3, 4, 4, and -1. Here is 6 and 2. Here is 8 and 3. After we got these, now we just have to find the path taken from here to here. So from here to here, that's going to be plus 4 meters. And from the yellow path, we get minus 5 meters. Because minus 4 minus, -1 minus 4 is -5 meters. And now, the red path, that's going to be 2 minus 1 meters, which is 2 plus 1 meters, so plus 3 meters. And this one, 3 minus 2, which is 1 meters, so plus 1 meter. And now we can clearly find the distance, which is equal to plus 4 meters plus minus 5 meters plus 3 meters plus 1 meter, so which is gonna be 13 meters. And now let's look at delta x, which is the final position minus the initial position. So the final position is here and the initial is here. So it's gonna be 3 minus 0, which is 3 meters.